Okay, here are the notes for complex numbers. So complex numbers occur when you try to take the square root of a negative value. So definition I is root -1, or I squared is equal to -1 itself. Complex numbers contain both a real and an imaginary component, so z equals a plus bi. A is the real component, b is the imaginary component. You can plot these on the coordinate axis, which we'll show on the very last examples. So for the first one, simplifying radicals, negative root 45. So what we actually want to start by doing is breaking it apart into the root of -1 and the root of a number. Because the root of -1 will always give us an I. And then for root 45, we'll have to simplify that factor tree. So 45 would be 3 and 15. 15 is 3 and 5. So we have a pair of 3's. So root 45 is 3 square root 5. Pair comes out, leftover number comes back. So to put it together, we have an I, we have a 3 root 5. So the final solution would be 3i root 5. So for root -3, so root -1 times root 3. Well, root 3 does not have any factors, but that can become I. So all we end up here is I root 3. As for -108, so -1 and root 108. So -1 gives me I. So for 108, that's even. So 2 and 54, still even. 2 and 27, 3 and 9, pair of 3's. So we have a pair of 2's, we have a pair of 3's. So when you do root 108, a 2 comes out and a 3 comes out for the pairs. That 3 doesn't have a partner, so it stays inside. So this would be 6 root 3 with the I, would give us 6i root 3. I kind of ran over my room for a -180. So root -1, root 180. So -1 is I. So for 180, that's 2 and 90, still even. 2 and 45. 45 is from up here, 3 and 15. 15 is 3 and 5. So we have a pair of 2's, we have a pair of 3's again. So 2 comes out, 3 comes out. 5 does not have a partner, stuck inside. So put together, 2 times 3 is 6, the I from the negative, and then root 5. So 6i root 5. Okay, so we also can have powers of I. You're not technically allowed when you do complex numbers to have any powers of I higher than 1. However, the powers of I are cyclical. So I to the 0th, anything to the 0th is 1. I to the 1st is a definition, anything to the first power is that. I squared, also a definition, -1. I cubed is I times I squared, which means it's I times -1, which means I cubed is -I. I to the 4th, we can do a similar trick. I to the 4th is I squared times I squared, which is -1 times -1, which is 1. And actually, the pattern just repeats. I to the 5th is back to I. I to the 6th is back to -1. I to the 7th is back to -I, so on and so forth. So in general, your rule is as follows. You take whatever your exponent is and divide it by 4, because it cycles every 4 values. If you get a whole number, 0, 4, after you do the division, your answer is going to be 1. If you get something that ends in 0.25, it's going to be I. Something that ends in 0.5, -1, so 0.5 would be here, first value. 25 or 5 would be here, 0.25 there, or 0.75 would give me -I. So if we come up here, 79 divided by 4 is 19.75. So 0.75, look at our rules, is -I. So this would simplify to just be -I. In the case here, where you have multiple things, we have to add our exponents first. That's the 67th power. So 67 divided by 4 is 16.75. So 0.75, once again, means that this is also -I. 104 divided by 4 is, I don't know, it's going to work out evenly, 26. So that is a whole number. So this is just 1. 11 divided by 4 is what? 2.75. So it ends in 0.75, so -I again. All right, last thing, is plotting. So when you plot complex numbers, you have a real axis, you have an imaginary axis. So that's the real part, that's the imaginary part. So 7 plus 5i is the same as the point 7 on the real, 5 on the imaginary. It's like plotting the point 7 comma 5. So 7 comma 5. Similar thing can happen down here. Negative 1 plus 9i. So negative 1 is the real axis, x. 9 is the imaginary axis, y. So negative 1 comma 9. Now, the thing to be careful of is if you have just a whole number, that's technically 2 plus 0i, or 2 comma 0. If you have just an imaginary part, negative 3i, that's 0, whoops, in this case, minus 3i, so 0 comma negative 3. So it is possible that maybe missing the I or the number part, you just insert zeros there. That brings us to the end of the section.